Hi, it's me, Anup Panta. So I'll be talking about ARP. So what is ARP? ARP stands for Address Resolution Protocol. It's like a little helper in our network that helps devices find each other's physical addresses, which we call MAC addresses, based on their IP addresses. So think of it like a phone book for devices on a network. How does an ARP packet look? So an ARP packet is made of a few key parts, and I'll walk you through them. So first one, hardware type, S type. So this tells us the type of hardware being used. For most networks, this is just one, which means Ethernet. Second, protocol type, P type. So this shows what kind of protocol is being used. For IP addresses, it's a specific code, 0x0800. Hardware address length, HLAN. So this just tells us how long the MAC address is. For Ethernet, it's usually 6 bytes. Protocol address length, PLAN. So similar to the SLAN, but this what tells us the length of the IP address, which is 4 bytes for IPv4. Operation. So this is like the mode of the message. It's either request 1 or reply 2. Next, sender hardware address, SHA. So this is the MAC address of the device sending the ARP packet. Sender protocol address, SPA. So this is the IP address of the sender. Next, target hardware address, THA. So this is the MAC address of the device the packet is meant for. In request, this is left empty. The last one, target protocol address, TPA. So this is the IP address of device the packet is targeting. Putting it together, imagine sending a letter with both your address and the recipient's address on it. An ARP packet is similar, so it includes the senders and targets, hardware and protocol addresses. So this packet helps devices on network identify and communicate with each other. That's basically how ARP works. So it's a simple but crucial part of how our networks function smoothly. Using the visuals from the images will help make it clear. So thank you. Yeah.
Hi everyone, my name is Jesse De Silva and my topic is the benefits versus the disadvantages of the Address Resolution Protocol or ARP for short. Now as we all know, ARP is a protocol or procedure that connects an ever-changing Internet Protocol or IP address to a fixed physical machine address, also known as a Media Access Control or MAC address, in a local area network, also known as a LAN. Now let's head on to the benefits of ARP. The first benefit of ARP is that it improves communication. Now how does ARP improve communication? ARP links the IP address provided to a device with its MAC address, thus enabling the communication of the concerned device with the other devices in the network. The next benefit is that ARP is compatible with a wide array of operating systems. Now ARP is a widely used protocol and is not dependent on a singular platform. Thus it is supported by every major operating system such as Windows, macOS and Linux among others. This basically means that ARP is platform independent. The third benefit that we will be discussing is that ARP improves security. ARP packets serve another function by discovering the MAC address of all of the devices on the network. This helps discover anomalies by identifying rogue devices and network intrusions of any kind that may be caused by hackers. The fourth and final benefit that we will be discussing is that ARP improves network performance. ARP cache tables are used to store IP to MAC address translation mappings for future reference. This improves network performance by reducing network congestion. Network congestion is reduced due to the lower number of ARP broadcasts required for optimal communication. Now, although ARP has numerous benefits, it also has a few disadvantages that must be taken into account. The first disadvantage is the presence of ARP spoofing. Now, ARP spoofing is a malicious attack where a hacker sends fake ARP packets to the LAN with the objective to connect their MAC address to the IP address of a trusted device that is connected to the network. This link enables data to be transmitted from the victim's device to the attacker's device instead of the intended recipient. Other names for this attack are ARP poison routing and ARP cache poisoning. The next disadvantage that ARP is susceptible to is a denial of service attack. A denial of service or DOS attack is aimed at denying one or more victims access to network resources. In the case of ARP, an attacker might send out ARP response messages that falsely map hundreds or even thousands of IP addresses to a single MAC address. This potentially overwhelms the target machine. This type of attack, sometimes known as ARP flooding, can also be used to target switches, potentially impacting the performance of the entire network.
Now, hi, my name is Jasprit Kaur. So my topic is common vulnerabilities. The ARP spoofing is also referred as a ARP poisoning. Is a security vulnerability in which the attacker broadcasts a fake message through the ARP. Hence, by drawing the default gateway to connect a valid web host or IP address in the current situation of this scenario, the MAC address of the attacker transforms into the objective. This method allows an attacker to analyze the traffic that goes to that AIP address or the filter and the traffic reaching the IP address. Another structure that can implement ARP spoofing attacks is referred to as a it ITERCAP and the ARP spoofing, which belongs to the sniff suite. Namely, under such an attack, the attacker can specify the exact IP address he is aimed at, and these tools drop a spoofed ARP message randomly. To my mind, ARP spoofing has another strong impact. Passwords, credit card number, or any other personal message that the user is sending could be intercepted by hackers, and this leads to theft. They can also control what is in transit in the data link layer by either adding unwanted and avaricious connections that contain payloads or changing previously established positive connections. Also, by broadcasting fake ARP messages to several network, an attacker can reach all the devices on the network. Thereby, ARP flooding is another is also resulting in a DDoS. ARP flooding is form of attack in which an attacker transmits a number of ARP requests or responses over network. Reference CV 1999 077 Such a stream of traffic is uncompromising, and coveraging at the network device may result in the crash of unavailability to the device on the other end of the network. The surface ARP list of the target may be flushed, and a valid ARP records may be replaced or removed. The ARP flooding has a negative effects as follow. Um, as the normal connections could be timed out or slowed down by the application with the flooding of ARP traffic in the network. This can also lead to downing of some of the devices, especially the one which have limited processing power. This is because the flood that accompanies the ARP can force the device to crash or restart. Another fatal threat is DNS spoofing by ARP exploitation. The CV number is C20030813. The attacker in this attack holds the communication pathway between the victim DNS server and the ARP poisoning. First, the attacker corrupts the ARP cache, uh, and he proceeds to corrupt the ARP cache, and Then they imitate the DNS server and response to the fake DNS queries from the user and redirect them to the fake sites. Even if a real address is entered, and the consequences of the DNS spoofing the are the user. The first one is that the user can get a fake link that leads to the site designed to capture passwords and other information necessary to the intruder. Also, malware distribution becomes an issue since when a user visits a website advertised by the attackers, they targeted the systems are infected. Moreover, the interception of DNS queries and response enables the attacker to monitor the internet activity of the victim and collect even more information. One of the example of this kind of attack is DNS spoofing is combined with ARP poisoning with the help of ettercap. All that is necessary for an attacker to perform an attack using an ettercap to infect the victim DNS server, and ARP-cache is to deliver fake DNS replies to the retweet victim's traffic. Thank you.
So basically, in order to keep going with the presentation, we would like to show some kind of attacks that we are doing in the presentation. One of it is ARP spoofing, that is a man on the middle attack. And basically, for this example, we're gonna have a simple setup with a client Kali server, Kali attacker, and a server where we're gonna try to spoof the a MAC address in the ARP table to get access of the communication, so we can get the information that the client is requesting to the server and vice versa. So basically, we're gonna start doing a host scan, where we're gonna find out that the entire network is gonna have one IP address that is 1.1 and 1.2, host and server, or server and host, that doesn't matter. But we can see that the MAC address on these examples ends up in 7671 and 0009. After we identify what's going on in uh, with every host that is in the network, um, we're gonna see if there is a communication between the client and the server, which we can do using a ping tool, using the CMD terminal. And also we can see from the host, the student, the ARP table using the command ARP dash A, and we can see that we got no same MAC addresses. So we got the 192.168.1.2 with a MAC address 0009, and we got the 1.10 with 9717. And after that, we got another host that those are DNS. But basically, we can see that there is just one MAC address per one host inside the network. After we start doing the packet capture with Wireshark, we can notice that we don't have anything because we haven't attacked yet. But after that, we can do port forwarding inside Kali, where we're gonna try to capture all the packets and resend those packets through the gateway to get the server, so we can act as a man in the middle attack. Using the tool Ethercap inside the Kali, we can do the sniffing, selecting the network interface, scanning the host, and then selecting what's gonna be our targets for the attack. We gotta target either the host and the server, because we gotta interrupt and be the bridge between the host and the server at the same time to not letting the host or the server to identify that someone is sniffing that communication. For this example, we just set up the targets that is gonna be the IP address 192.168.1.1 and 192.168.1.2, and we're gonna do an ARP poisoning. So we're gonna start injecting ARP MAC addresses, and we will copy one of those addresses to seem like we are the real server. In this case, we're going to sniff the remote connections, and then we're going to see that all the traffic between the source 192.168.1.1 going to 192.168.1.2, it's being captured. So we are in the middle listening and sniffing all the communications between the host and the server. Also, if we go to one of the host or the server and we execute the ARP-A command into the terminal, we're gonna see that we have here one more IP address that is 1.67. This is the attacker. This is the Kali machine, and as we can see here, we are injecting and modifying the ARP table. We can see that all the hosts will have the same MAC address. This will make a confusion in the middle of the network, allowing us to act as a bridge inside of the network and sniff all that traffic. That's ARP spoofing, because we're labeling, we're masking our real MAC address with with a different MAC address. For a second example and the second attack that we are addressing in this presentation, we're gonna go about the DNS spoofing. This DNS spoofing be will be performed after we did all the spoofing that we presented before. But the difference with DNS spoofing is that we're gonna try to redirect all the traffic to a fake network, to a fake DNS. But how we're gonna do that? We can use the social engineer toolkit set. This is Station X infography. So we can use that toolkit to attack. And doing that, we can set the DNS spoof domain as the domain that we want to redirect all the traffic. That's going to be myfacebook.com. And then we're going to start doing the attack, doing DNS spoof on. In that way, all the users that are going to ask what's the address of that domain will be redirect to the MAC address, to the IP address 192.168.37.120. That is 128. That is a private IP, not the public IP of Facebook. So they will be accessing a fake fake domain with a fake network. So basically, all the ARP attacks, DNS, the DOS and spoofing will have the same vector, but some of the final steps on the attack will change depending what's the objective of the attack.
Hi, my name is Kirtori Shanmukeshwar. So today my topic is mitigation on ARP protocol. So the first mitigation step is port security. So the port security is a type of mitigation strategy that we use on switches, which basically allows to limit the number of MAC addresses that can be learned on a port. And by setting a maximum limit, we can prevent unauthorized devices from connecting to the switch. And also, if the limit is exceeded, so the port can either be disabled or can be put in a secure mode to mitigate potential security risks. And the second mitigation strategy is DHCP sniffing. So DHCP spoofing it helps to prevent unauthorized DHCP servers from issuing IP addresses to different to anonymous users by filtering DHCP messages based upon trust levels. And by configuring DHCP snooping, we can designate trusted ports connected to the legitimate DHCP service, ensuring that only the messages from these trusted sources are processed and others are discarded. And the next strategy is ARP inspection. So ARP inspection is a type of strategy where it scrutinizes ARP package to validate that the IP to MAC addresses mappings are legitimate and verified. And by enabling ARP inspection on switches, it ensures that ARP packets are verified against the DHCP snooping database or on the static ARP entries. So thus by protecting against ARP spoofing is allowed only by authorizing ARP traffic. And coming to the next one is static ARP entries. So to safeguard critical devices from ARP spoofing, it is advisable to disable dynamic ARP entries and configure strategic ARP mapping. So by manually defining IP to MAC address space, we can ensure that only valid ARP replies are accepted, which in turn helps in maintaining network integrity and prevents spoofing attacks. And the last mitigation strategy is network segmentation. So network segmentation means that segmenting a network using VLANs, which reduces the impact of ARP spoofing by confining it to isolated segments. So by implementing VLANs and applying cloud ACLs, which are uh, access control lists to restrict inter-VLAN traffic, which can prevent ARP spoofing attacks from affecting other segments, thus by ensuring overall network security.